Alright, another day of another Leetcode problem. Today is the 11th day of my daily commitment. So we have to find a common array of two array. So that is quite similar to the yesterday one. Okay, let's continue reading it. We are given two zero index integer permutation. So A and B of lunch n. So technically that means the lunch of given array A and B must be the same size. And then a prefix common array of A and B is an array of C. So we have to compute the new array C such that index in the C is equal to the count of the number that present at or before the index I in both A and B. So we have to return the common array of A and B. So a sequence of n integer is called permutation. So the permutation here is a different definition about how can we create the permutation. So let's start understanding the problem first before we deep dive into the coding. So we have two input array in here. Let's consider we are at the index 0. Let me write down the exact value in the right side. And 4. And next is 3, 1, 2, and 4. So we have originally at the index 1, right? The same for the second array. So they both are not common for sure. So if I have to found the new array, so the index 0 will be originally 0. So moving forward, now at the index 1. So we need to consider the whole array of 0 to 1 for the array A, the same for the array B. Now we have two numbers in common, 1 in here, 3 in here. Because we are seeing these as something like this. 1, 3 in here, 1, 3 in here. So we don't need to take care about what are the order of the given array. We just need to keep track of what are the less index we need to scope out for the array. So given that, we will probably get the count of 2 because 1 is here, 3 is here. So 1 and 3 is total calculation will be 2. So moving forward to the index 2. Now we have 3 number, 1, 2, and 3. 1, 2, and 3 also. So maybe increase the array size like this. So that is going to create the 3. Same for here at the 4. So if we reach to the end of the array in here, and then we probably increase like this. So hope you guys understand the problem first before we start deep dive into the coding. Okay, second example. So the same approach we can do in here. Let me prepare a little bit first before we start coding. So we have things like 3, 1, 2 in the array of the second one, and then 2, 3, 1 in here. So originally we are at the index of 0, which means we have 0 permutation in here. So moving forward, so we should have 1 only because there's only number 3 are the same. So maybe 0, 1, and the last one will be 3 because we have 3, 1, 2 in here and 2, 1, 3. Whatever we do for the order, that will be the total count of 3 for permutation array. Cool. And let's start the brute force approach that we can think of it. Let's call answer array. Just create like this. Answer integer array, and we're gonna go through live from index of maybe we will create the cow, because I'm pretty sure like the size of array A and B were exactly the same. Cow, and I want to go through from 0 through cow, because we don't need to worry for the last one. And what I want to do in here is let's call at scope A, and I will scope out like index in here. The same for here. Scope B will be B of index. Or let me return the answer in here first. And what I want to do is I want to show what I am doing exactly here. So let's consider like scope A and scope B. Let me run and show what is this 3 dot and let's index exactly doing. So technically we are scoping out by the index. So index 0, that would be 1 in here, 3 in here. So we got 1 and 3. So 1, 3 for the index of 1 and 3, 1 for index of 1 for the second array. Cool. So how can we do it? We have something called set data structure. We can put in that to ignore the order of set A or set B. So in that case, how about we change the variable to the scope to set, because we are putting the set. In set, there is a one mathematic function. What we're going to do is let's call set C. That will be the set A dot intersection and set B. So if you want to do, the answer of index will be no, it better be a pen. Set C dot count. Yeah, for those who are very new to the intersection, so the intersection is just finding the common values from two different arrays. In here, we can see like Bethany and Eric's are the only two values that's common across two arrays. Right, and that is very handy. So let's try to run locally first. Okay, there is something wrong. Okay, I may put the ads as initially. Cool. So if we submit it, that will probably work. But we have one problem in here. Every time we are going through from original index of 0 to the end of the index. So we are scoping the array again and again. That is creating the O of n square. So we only have one chance to do the analytics of our program. Let's use the incorrect one first. We were trying to tune the performance later on, because I want to prove that that is technically not the optimal approach. You guys may see that we are seeing like O of n square for the runtime complexity and O of n for the memory. So that is correct. How do we improve that to become O of n? So my thinking was maybe how about we use something called frequency. Let's call frequent better, because frequency will be the quite confusing naming. We're gonna put the one array repeating of 0 to the count. Yeah, so let's create the array the same size as a count, and we don't need that set anymore because we want to become the O of n instead of O n square in the runtime complexity. So what I was planning to do is maybe we will check like if the frequency of index. So if I have to visualize properly, I just create in the extra one more array in here. Let's consider like 0 and 0 for the extra array. And I'm gonna check every time I'm facing the frequency in here. Let's try to write a little bit in here first. So we'll start with the first array index. And what I will do is I may probably need to do the -1 for index. The reason why I'm doing the index 1 is if we can see that all the values inside the array are start from the value of 1, not from the value of 0. So every time we access in here, we need to detect the -1, and then I will probably increment into 1. Because what I'm incrementing is, what I'm trying to check is, okay, let's write first. So let's say I'm in index 2. What I'm going to do is go and check the index 1 in here. So 2 minus 1 is 1. So I will check that value is already there or not, which is index 1. If not, I'm going to increment it. So how I'm going to increment it, just doing the +1 here in line number 7. If yes, what I want to do is I will check like frequency of a of index -1 is equal to 2. I may need use the one more variable called common equal to 0. If it is same, I will increment the common to 1. Right? The same for the second array. Let's call frequency of b of index -1 plus equal to 1. And if frequency of b of index -1 is equal to 2, I will increment the common valuation to 1 again. At the end, I will append to the result. Cool. And no, not the result, should be the answer. How can I create a route? Let's try to run locally first. Okay, we have some issue in here. That should be for because we want to change the frequency array along the program. Right, that solved the issue, but it will be a little bit complicated to understand because we are detecting -1 in every place. The reason to detect the -1 in here is the values inside the given two array is start from value of 1, which is provided in the constraint. But if we want to simplify that, we can simply +1 to the count of the frequency array and we can remove it, or the -1. So why increment the size of the array to 1? Well, I have a proper answer. How about we increment the 1 value in here, which will just change any spacing, but it's just a minor spacing. But we were not using it, but we will start using it from the, according to this, we will start using from the index of 0, which is true, because we are not doing the -1 anymore. So it is probably start from here, and then we will go through from 0, 1, 2, and then we will only use this portion of the array for frequent. And then this is extra just for the sake of value start from the 1. Wait, I make a mistake. It should be like that. because since start from the index 1, so it should be like this. So we will not use that anymore. We will start using like this. All right, and that is okay. We are not going to bind the premium for sure. So by checking that, that is definitely the O of n for the time complexity and O of n for the space complexity. All right, hope you guys enjoyed my solution and see you in the next one. Bye.